What if the ocean had a heartbeat? Listen, that's the sound of the healthy coral reef. Its complex bioacoustic signature, a sign of thriving ecosystem. And that is the sound of the ecosystem in distress. The vital sign is fading. The problem is, we have lost over half of the world's coral reef. We are in race against the time, and listening to thousands of audio clips manually is impossible. We ask, what if we could build a stethoscope for the ocean? An AI that could check its vital sign in seconds.
Our challenge was to quantify this noise. The difficulty isn't just to find speech, it's to classify an entire complex acoustic environment. This led to our core technical architecture, a two-stage transfer learning pipeline. We didn't need to build it from scratch. Stage 1 is I/O. We used Google Surf model as a high-performance feature extractor. We feed it 5-second 32 kHz audio chunk, and it provides a 1280 dimension fingerprint or embedding. Stage 2 is our brain, Coral Mind. This is the custom classifier we engineered. We chose a random forest classifier which is highly effective at learning from these complex fingerprints and making an accurate final decision. Coral Mind is trained to analyze those embeddings and make the final critical diagnosis: healthy, degraded, or anthrophonic.
Let's begin our demo with the Acoustic Reef homepage, the digital front door to our project and vision. Right here, we introduce our core mission, using AI and bioacoustics to revolutionize coral reef health monitoring. The homepage quickly walks you through the problem of reef decline, why traditional monitoring falls short, and how our approach offers real-time accessible solutions. Through clear visuals and concise information, we highlight the urgency of ocean conservation and introduce our innovative technology in a way that's accessible for everyone, from scientists to the broader public. When you are ready to experience our technology firsthand, just click Try the app to access our interactive analyzer, where the real magic happens. The link to the full website is in the video description. Feel free to explore. After exploring our website, let's dive into the real power behind Acoustic Reef, the AI analyzer. This is where users can upload their own recordings and get an instant assessment of reef health. The process is simple. First, upload an underwater recording. Just like this, you can add multiple files for batch analysis or analyze a single clip for quick results. Our analyzer checks the recording for duration, quality, and standardizes the sample rate to ensure the most accurate results. Once the analysis is complete, see the audio spectrogram and dive deep into the results. Reef health status is predicted. Here it's flagged as degraded with medium confidence. Noise pollution level gives immediate insight into human impact. You get a visual map of the acoustic environment, including specific noise sources like boat engines alongside a breakdown of the AI's confidence in each category: healthy, degraded, or anthrophonic. But beyond diagnosis, the analyzer guides action, suggesting conservation steps for critically impacted reefs. Every user receives tailored recommendations from reported vessels activity to implementing quiet zones and monitoring water quality. If you wish, you can even submit a report or contribute findings to local conservation efforts. For larger monitoring projects, we have built batch analysis. This feature lets you analyze multiple underwater recordings at once for a comprehensive reef health report. Simply drag and drop your audio files here or select them from your computer. You can upload dozens of hydrophone recordings, each up to 200 MB. Once your files are in, hit Run Batch Analysis. The AI works through every file, standardizes sample rates, and gives rapid predictions for each one, flagging them as healthy, degraded, or anthrophonic. You get instant summary statistics, the proportion of healthy and degraded recordings, errors if any, and download option to save a complete CSV report for further analysis or sharing. Batch analysis also unlocks advanced tools like 3D acoustic space, allowing you to visualize how your recordings cluster based on their sound characteristics. Each point is a file, and you see at a glance the diversity and health patterns across all your data. Hover over any point for details. Rotate and explore the acoustic ecosystem, critical for large-scale research projects, surveys, or conservational monitoring. Finally, you can download the full results to share, track changes over time, and drive science-based conservation action. Let's explore one of our most powerful features, the Acoustic Map diagnostic tool. The section transforms your reef recordings into real, actionable insights for conservation. The map below visualizes hundreds of acoustic samples, automatically clustering them into diagnostic zones based on sound pattern similarity. You will see summary statistics for each zone, how many recordings match each cluster, the percentage that are healthy or degraded, and overall diagnostic coverage for your project. In fact, at a glance, you can track total healthy reefs detected, degraded reef count, noisy areas impacted by human activity. Want real-time feedback? Upload any recording to see where it falls in the acoustic landscape. The tool analyzes your file, locates it in one of the zones, compares it to known healthy degraded neighbors, and provides instant diagnostic insights. It also runs a neighbor analysis, showing which cluster your site matches and details about the closest recordings. You can download all results for further research. This is our Geo-Acoustic map. Each point connects a real reef recordings to its location. Green means healthy, orange means degraded, red means noise or pollution. Zoom in, click around, and instantly see where reefs need help. Science meets the map, so action is just a click away.
Building a reliable classifier was a significant technical challenge for us. Our first iteration version 1 failed.
It was heavily biased. We fed it test data and it classified nearly every single sample as degraded, rendering it functionally useless.
It was a critical moment. We diagnosed the problem. The problem was severe class imbalance in our training set. The model wasn't learning, it was exploiting flaws in our data.
We re-engineered our entire data pipeline, ensured our classes were balanced, and retrained Coral Mind. This proves that for an AI, good data set is everything.
Now let's come to the recap. We have built an end-to-end pipeline for the ecosystem health. First, we have used the surfers as an ear and trained our Coral Mind as a brain. And we have used our own dashboard as an analyzer. This is a rigorously tested prototype. Our next steps are to move to the real-time threat alert and train our AI to identify specific key species. If you may know, you started by asking, what if the ocean had a heartbeat? Today, we can confidently say, yes, it does. With the help of Acoustic Reef Analyzer, we have able to achieve it. We have built the stethoscope. For the first time, we all can listen to it. Thank you.